Morning students, I am Anitha. I am working as assistant professor in the Department of Artificial Intelligence and Data Science of Beltech Multitech Dr. Rankarajan, Dr. Sakunthala Engineering College. I am going to present the video lecture on Artificial Intelligence and Machine Learning Overviews. The course name is Machine Learning Techniques and the course code is 231AI521. I am going to handle the course for third year, fifth semester students. Now we are going to discuss about the following topics. First topic, Introduction to Artificial Intelligence and Real World Applications. Second topic, Introduction to Machine Learning and its Real World Application. Then types of machine learning and machine learning life cycle. Now we are going to discuss about the artificial intelligence. What is artificial intelligence? Is the simulation of human intelligence in machines. Artificial intelligence enables the machine to perform tasks like learning, reasoning, problem solving, and decision making. The main aim of AI is to create a system that can mimic or replicate human cognitive abilities. AI is the technology that allows the system to replicate human behavior and thoughts. The artificial intelligence uses many algorithms to train dataset that will generate AI model that let computer system perform tasks like recommending songs, googling route direction, or providing text translation between two languages. The few examples of AIs are ChatGPT, Google Translate, Tesla, Netflix, and many more. Now we are going to discuss about what is the AI goal and what is the contribution. Now, what is the AI goal? The potential of AI is basically to mimic human skills and traits and apply them to machines. The main objective of AI is to create a core technology that is able to allow the computer system to process intelligently and independently. It is used to create the expert system and to implement human intelligence in machines. It is used to create a develop problem solving ability. It is used to allow continuous learning and it is used to encourage social intelligence and creativity. So what is contribute to AI? AI is a field that combines various scientific and technological disciplines which include computer science, biology, psychology, linguistics, mathematics and engineering. The main objective of AI is to develop computer programs that can perform tasks with reasoning, learning and solving problems similar to a human intelligence. Now we are going to see about the artificial intelligence history. Carl Play named Rosen Universal Robot opened in London, the first use of the word robot in English in the year of 1923. John McCarthy, a professor at Dartmouth College, coined the term artificial intelligence in the year of 1956. Joseph Weizenbaum created Elisha that used natural language processing to make conversation with the humans in the year of 1966. Deep Blue was the first program to beat a human chess champion, Gray Kasparov, in the year of 1997. AlexNet is a convolution neural network architecture that was designed by Alex Krzyzewski in the year of 2012. OpenAI started beta testing GPT-3, a model that uses deep learning to create code and content and other creative tasks in the year of 2020. Now we are going to see about the key technology in artificial intelligence. Already we discussed what is artificial intelligence. Now how artificial intelligence work in the world. So first we talk about the data and knowledge. Artificial intelligence systems are built upon large database and knowledge bases. Then next technology is machine learning. This core technology allows systems to learn from data, identify patterns, and improve their performance without being explicit programmed for every task. So next technology is deep learning, a subset of machine learning that uses artificial neural network with multiple layers to learn from complex data, leading to more advanced capabilities. The next technology is natural language processing. Natural language processing enables the computer to understand, interpret, and generate human language, both spoken and written. And the next technology is computer vision. The artificial intelligence subset allows machine to see and interpret visual information such as images and videos. The last technology is robotics. So nowadays we have used many robotics. They are developing the robotics, AI powered physical systems performing tasks autonomously. Now we are going to discuss about types of artificial intelligence. Artificial intelligence can be classified into two main categories based on its capabilities and functionality. Now we are going to discuss about based on capabilities. Under the based on capabilities, we are going to see three types. First type, call it as narrow AI, otherwise called weak AI. This type of artificial intelligence is designed to perform a specific task or a narrow set of tasks such as voice assistant or recommendation systems. It is good in one area like recommending product or recognizing speech but lacks in general intelligence. Next type, general AI, otherwise called strong AI. This type is theoretical concept where artificial intelligence can perform any intellectual task that a human can do. It shows human-like reasoning and understanding across multiple domains, making it capable of tackling a variety of tasks. And the next type, super intelligent AI, otherwise called super AI. This type of AI, hypothetical form of AI, that would surpass human intelligence in all areas. It would be capable of performing tasks more efficiently and effectively than humans. And the next category based on functionality, under the category we are going to see four types. First type we call it as reactive machines. These artificial intelligence systems only react to specific tasks without storing past experiences. They don't learn from previous action but respond in a set way. For example, this is game chess playing AI that evaluates the board and makes a move based on their current position. The next type, limited memory. These AI systems can use past data to improve future decisions. Say example, self-driving car. They use data from previous trips to navigate roads and avoid obstacles. Next type, theory of mind. The theory of mind is a theoretical type of AI that would be able to understand emotions, belief, intention, and other mental states. This would allow the AI to interact with humans in a more natural and empathetic manner. The last type, we call it as self-aware AI. This type AI is a hypothetical form of AI that possesses consciousness and self-awareness. It would have an understanding of its own existence and could make decisions based on that awareness. Next, we are going to discuss about artificial intelligence advantages. Artificial intelligence offers a range of benefits that improve productivity, decision making, and user experience across multiple sectors. So we have listed different type of advantage. First, we are going to see efficiency and automation. What is efficiency? Artificial intelligence automate repetitive tasks, smoothen workflows, and reducing human error. This helps us save time and concentrate on more strategic and innovative tasks. So next, improve decision making. AI ability to process and analyze large data set help business and individuals make informed data-driven decisions. This is beneficial in sectors like healthcare, finance, and retails. So next one, personalization. It helps personalize experience by analyzing user preference and customizing recommendation. This enhances user satisfaction as in platforms like Netflix, Amazon, social media feeds. So the last one, 24/7 availability. So unlike human, AI can operate continuously without rest, making it ideal for round-the-clock tasks such as customer support, security monitoring, and data collection. Now we are going to see about the challenges and ethical concerns of AI. AI have some challenges which need to be resolved. So first challenges we are going to discuss about data privacy and security. Artificial intelligence systems require vast amount of data which can raise concern about data privacy and protection. Ensuring sensitive information is secure and maintaining a user trust is a significant challenge. And the next one, algorithmic bias and fairness. It can inherit biases from the data they are trained on, leading to unfair or discriminatory outcomes. Addressing these biases is important for ensuring AI systems make impartial decisions. And the next one, job displacement due to automations. It automates tasks traditionally performed by humans. Concern about job losses in certain sectors arise. Ensuring a smooth transition for workers and retaining them for new roles is essential. And the next one, lack accountability and transparency. AI model, especially deep learning, can often act as black boxes, making it difficult to understand how they make decisions. This lack of transparency can be problematic in areas like healthcare or law enforcement. And the last one, ethical decision making in AI system. The use of AI in sensitive areas like surveillance, autonomous weapons, and decision making raises ethical questions. Finding a balance between technological innovations and ethical accountability remains a continuous challenge in AI development. Now we are going to see about the futures of artificial intelligence, where we have to use futures. First, we have to already we discussed about the what is AI and how it is working. Then, so we have to use the AI in the future. Integration of artificial intelligence with the emerging technologies like IoT, blockchain, and quantum computing. And the next one, development of explainable or transparent AI. Increase the use in healthcare, education, and sustainability. Then progress toward general AI capabilities. Finally, ethical and legal framework for responsible AI. Now, we are going to discuss about the applications of artificial intelligence. Artificial intelligence has many practical applications across various industries and domains. So now I have listed many applications of AI. Now we are going to see about the first one, healthcare. Artificial intelligence helps in early diagnosis and treatments recommendation by analyzing medical data such as images and patient history, improving preventative care. So these are the areas we have used. AI assisted medical diagnosis and treatment, drug discovery and development, personalized healthcare and predictive analytics, medical imaging and radiology, virtual health assistant and chatbot. Now we are going to see the next area, finance. Artificial intelligence in finance detect fraud, analyze market data, and automated risk management. It also assists in personalized investment advice, helping individuals make smarter financial decisions. So these are the areas we have used. First, fraud detection and prevention, algorithmic trading and investment analysis, risk management and credit scoring, customer service chatbot, personalized financial planning. Now we are going to discuss about the third applications, education. So in the area, we have developed the intelligent tutoring system and we can create personalized learning path and we can develop automated grading and assessment. We can create virtual class with AI support and we can use the language translation and learning assistance. Next area, we discuss about transportation. So transportation, we can develop the self-driving car and autonomous vehicle. We can develop the traffic prediction and management. We can create route optimization and logistics. We can develop smart public transport system and we can create drone-based delivery systems. Now, next area, business and customer service. AI-powered chatbot handle routine customer inquiries, provide support 24/7 and scalable more complex issues to human agent. This improves efficiency and reduce wait times, enhancing overall customer experience. So these are the areas we can use. We can create AI-powered chatbot and virtual assistant. We can develop customer behavior analysis and recommendation, can predictive analytics for business strategy, can create sales forecasting and supply chain optimization. We can develop automation of repetitive office tasks. Now we are going to see about the entertainment and media. So in this area we can create recommendation, content recommendation like Netflix, YouTube, Spotify. Use the recommend the content. And then next we can create the AI generated music, art and writing. We can develop gaming with adaptive AI opponents. Next we can create film production and visual effect. We can use social media content moderation. So these are the applications of AI. Next we are going to see about the security and defense. This is the main applications of the AI. Why I am saying is security is a main thing today world. So we have created the AI based surveillance and threat detection, can create cyber security and anomaly detection, and we can use military robotics and autonomous drones. And we can use predictive policing and crime analysis. We can identify verification and biometric security. So this is the next we are going to see about the future direction of artificial intelligence applications. So what are the future directions? Artificial intelligence in agriculture for precision the farming. Next we can create the smart city with the AI based infrastructure. And we can create climate change prediction and environmental monitoring. We can use AI in legal, journalism and creative industries. Then we can integration with IoT, blockchain and quantum computing. So this is the future direction of AI application. Now we are going to discuss about machine learning. What is machine learning? It's a branch of artificial intelligence that enables algorithm to uncover hidden patterns in the data set. Machine learning allows them to predict new, similar data without explicit programming for each task. Machine learning finds applications in diverse fields such as image and speech recognition, natural language processing, recommendation system, fraud detection, portfolio optimization, and automating tasks. Machine learning impact extend to autonomous vehicles, drones, and robots, enhancing their adaptability in dynamic environment. Now observe the picture. So what is machine learning? So we can take the data from different sources and training the data with machines and build the model. Finally, we predict the output. So this is machine learning. So what will they take input? See one example. We take the stock input as stock data, customer transaction data, streaming data, email, text, whatever we take input from different source. We have used machine learning techniques. So many techniques are we used in machine learning. Such as recursion, clustering, association rules, and classification. So using these techniques, we can create the model and produce the output. So what type of output we have produced? Stock price prediction and segmentation and next we are going to see machine learning's need and applications of machine learning. So why we need machine learning? Machine learning allows computer to learn from data and improve their performance on specific tasks without being explicit programs. We already said that. This ability to learn from data and adapt to new situations make machine learning particularly useful for tasks that involve large amount of data, complex decision making, and dynamic environment. So here are some specific areas where machine learning is being used. First areas we talk about predictive modeling. Machine learning can be used to build predictive models that can help business make better decisions. Say an example, machine learning can be used to predict which customer are most likely to buy a particular product or which patient are most likely to develop a certain diseases. And the next area, natural language processing. Machine learning is used to build systems that can understand and interpret human language. This is important for applications such as voice recognition, chatbot, and language translation. And the next area, computer vision. Machine learning is used to build systems that can recognize and interpret images and videos. This is important for applications such as self-driving car, surveillance system, and medical imaging. Next one, fraud detection. Machine learning can be used to detect fraudulent behavior in financial transaction, online advertising, and other areas. And the last one, recommendation system. Machine learning can be used to build recommendation system, send product, services, and content to user based on their past behavior and preference. Now we are going to see about differentiate between machine learning, traditional programming, and artificial intelligence. First, we look at the machine learning. What is machine learning? We already discussed, but once again we have remember the points. It is a subset of AI focusing on creating algorithms that learn from data and make predictions. It's a data-driven, learn from historical data to predict future outcomes. It is capable of finding patterns and insight in large data set, learning and improving over time. Is used in predictive analytics, autonomous vehicles, chatbots, and other AI-based applications. It is dependent on the quality and diversity of data. Can perform poorly if data is not representative. Then we are going to see traditional programming. Already we studied traditional programming. We have used writing the rule-based deterministic code based on specific problem statement. Is used in rule-based or deterministic rules on explicit instruction from developers. So lack of self-learning capabilities, output is directly tied to input and predefined rules. And it's used to build applications with specific functionality like software tools and systems. It is dependent on the intelligence and foresight of developers, limited to no scenarios. Then we are going to see artificial intelligence. What is artificial intelligence? We already discussed about previous slides. So once again, remember this same points. It is a technology that enables machine to perform tasks that typically require human intelligence. Uses a mixes of data-driven techniques and predefined rules, incorporating machine learning, deep learning, and traditional programming. It can adapt and evolves to perform complex tasks with high accuracy, often exceeding human. Now we are going to discuss about the machine learning life cycle. What is machine learning life cycle? This is a cyclic process. On the right hand side, we have observed that one diagram. So this is the life cycle of machine learning. We have seen different type of stages when we develop the machine learning model. So machine learning life cycle is a structured process that guides the development and deployment of machine learning models. It encompasses several key stages from defining the problem to monitoring the deployed model. The cyclical process ensures models are effective, accurate, and align the business goals. The first stage we call it as business goal identification and problem definition. The initial stage involves clearly defining the business problem that the machine learning model will address. It's crucial to understand the desired outcome and the specific questions the model needs to answer. And the next stage we call it as data collection and preparation. So under this we have three categories. First one, data collection. We are gathering the relevant data from various sources like database, API, files, etc. This is essential. The next process, data pre-processing. We have cleaning, transforming, and preparing the data for model training. This includes handling missing values, outlier, and inconsistency. And the next process is future engineering. We have selecting, transforming, and creating a new features from the raw data to improve model performance. The next stage, model development. So under the model development, we have four categories: model selection, model training, model evaluation, and model tuning. What is model selection? We have choosing the appropriate machine learning algorithm like linear regression, decision tree, neural network based on the problem type and data characteristic. And next we are going to see model training. We have training the selected model using the prepared data to learn pattern and relationship. Next process, model evaluation. We have accessing the model performance using the evaluation metrics like accuracy, precision, and recall, and a separate validation set. And the next process, model tuning. Model tuning is optimizing the model's hyperparameter to improve its performance. And the next stage is model deployment. We have integrating the trained model into a production environment, making it available for prediction or other tasks. This can involve deploying the model as an application programming interface, embedding it into an applications, or using it in a cloud-based service. The last stage is model monitoring and maintenance. We have continuously monitoring the model performance in the real world to detect any degradation or drift in accuracy. We have retraining the model with new data or adjusting its configuration as needed to maintain optimal performance. Now we are going to discuss about machine learning types. So we have the machine learning can be categorized into four types. First type we call it as supervised learning, second one unsupervised learning, third one semi-supervised learning, and fourth one reinforcement learning. So under the supervised learning, we have different type of techniques used. So first one recursion, second one classification, and third one deep learning. So under the recursion, we have seen two types, linear and polynomial. Under the category of classification, we have seen four: logistic regression, support vector machine, artificial neural network, and decision tree. Under the deep learning, we have seen two types: convolution neural network and recurrent neural network. And next we are going to discuss about unsupervised learning. So what is unsupervised learning? Next slide we have to explain. So under the supervised learning, we are going to see clustering, dimensionality reduction, and anomaly detection. So under the clustering, we have seen k-means clustering algorithm, and the next one PCA, dimensional data explain personal component analysis. And the third type we call it as semi-supervised learning. So it is under the semi-supervised learning, we have seen two types, self-training and low-density separation model. And the last type, we call it as reinforcement learning. So in this type, we are going to study dynamic programming and Monte Carlo methods. So machine learning types can be categorized into three types. So we are going to see supervised machine learning. It is the one of the type of machine learning. The supervised learning algorithm are trained on labeled data set. They learn to map input features to target based on labeled training data. There are two main types of supervised learning. First one, regression. Regression means regression algorithm learn to predict continuous values based on the input feature. The next one, classification. Classification algorithm learn to assign input data to a specific category or class based on input feature. The output label in classification and discrete values. The next type, supervised machine learning, unsupervised machine learning. Unsupervised machine learning learn to recognize pattern in data without being explicitly trained using labeled example. The goal is to discover the underlying structure or distribution in the data. There are two main types of unsupervised learning. First one, clustering. Clustering algorithm groups similar data points together based on their characteristics. The goal is to identify groups or cluster or data points that are similar to each other while being distinct from other groups. Next one, dimensionality reduction. Dimensionality reduction algorithm reduces the number of input variables in the data set while preserving as much of the original information as possible. This is useful for the complexity of a data set and making it easier to visualize and analyze. The third one, semi-supervised learning. It is a combination of both structured supervised learning and unstructured supervised learning. The last one, reinforcement machine learning. So in any agent learn to interact with the environment by performing action and receiving rewards and penalty based on its action. The goal of reinforcement learning is to learn a policy which is a mapping from state to action that maximizes the expected cumulative rewards over time. So there are two main types of reinforcement learning. First one, model-based reinforcement learning. Model-based means the agent learn a model of the environment, including the transition probability between states and the rewards associated with each state action pair. The agent then uses the model to plan its action in order to maximize its expected reward. Next type, model-free reinforcement learning. The agent learns a policy directly from experience without explicitly building a model of the environment. The agent interacts with the environment and updates its policy based on the rewards it receives.